Welcome, everyone, to our webinar, The Autonomous Supply Chain. I'm your host, Helen King. The future is upon us, and the autonomous supply chain becomes more of a reality every day. But what does that mean for supply chain companies today? What can companies do to adapt and stay competitive in the ever-evolving supply chain? Today, Lora will discuss the reality of today, the vision for the future, and the steps to take moving forward. Before I hand this over to Lora, there are a few things I want to cover with you. We're recording today's session, and we'll post it to our on-demand webinars page. You can visit our website to listen to this or any of our other webinars. Additionally, we'll send out the slides to all attendees within 24 hours of the broadcast. We encourage you to share these slides with others in your organization, and if you have any questions, please reach out to Lora or myself to set up a discussion. We want to hear your questions and ideas on this topic as well, so please post to the chat or the Q&A function to the left of the screen. We've left time at the end of the webinar to address your questions. Finally, we will be live tweeting the webinar, so if you'd like to join the social media conversation, you can use the hashtag SCIWebinar and the handle SCInsights during the event. Let me introduce you to your host, Lora Cecere, founder of Supply Chain Insights. As an enterprise strategist, Lora focuses on the changing face of enterprise technologies. Her research is designed for the early adopter seeking first-mover advantage. She comes to the stage with over 40 years of diverse supply chain experience. Welcome, Lora.
Hey, thank you so much, Helen. And it looks like this was quite a popular topic. We had almost 400 people sign up for the webinar. So you may hear people beeping in and out from time to time because it's just so popular. You know, the autonomous supply chain is not an evolution, it's a disruption. And so one of the things that I want people to really sit back and think about is that today's supply chain is stuck, that 90% of companies are struggling to drive balance sheet improvement. And the companies that are making the most improvement on the autonomous supply chain are companies like Google and Amazon. I remember Kiva, which was a warehouse automation system that really was out there for about a decade and not much was happening. And then Amazon bought Kiva for robotics in the warehouse and to drive an autonomous pick, or a pick that requires significantly less labor and was automated with the e-commerce processes. You know, if you go to the West Coast today in the U.S., you'll see Google testing autonomous vehicles. And autonomous vehicles are driven by sensors and also higher level of cognitive computing. And the advancements in sensors and cognitive computing and the adaptation of autonomous vehicles with autonomous warehousing will lead us to the topic that we're going to talk about today, which is autonomous planning. Now, as we think about planning, we've had planning and supply chain planning applications since the late 1980s. We started with client server, then we evolved through 32-bit architectures and 64-bit architectures, and now we're in a world of in-memory, and we also see a rapid advancement of technologies to aid planning. But, you know, planning systems require big wings and big feet. It's not about fads. It's about really having a vision, going after a vision, and being clear on what you want as outcomes. What I often find is that people will put in planning systems that won't be used or don't really drive the outcomes because people are not ready to focus on planning. You know, planning is about the important, and most supply chain leaders are very focused on the urgent. And if we focus on the short term and the urgent, we really cannot drive a higher level of performance in this supply chain, which is a complex, nonlinear system. And as the supply chain has become more complex with the long tail, the nonlinearity has grown. And so, therefore, it's harder to get balance in a balanced portfolio of growth, profitability, which we do a lot of modeling of operating margin, inventory turns, and complexity. And as companies move from a vertical siloed mentality to horizontal processes like sales and operations planning, new product launch, revenue management, supplier development, balance of these metrics is really critical. And since it's nonlinear, the use of linear optimization, as we've done in the last 2 decades, is not sufficient. And what happens is people struggle because they want to drive improvement, but unfortunately they're stuck in some paradigms that I'm going to ask you to shift. So as we think about the autonomous supply chain and we think about planning, one of the paradigms that we have to think hard about are the Excel ghettos that we've created within our organization, where people want to put everything into rows and columns, transactional data into rows and columns, and then we apply linear optimization to that relational data view. As we move into the autonomous supply chain, we are going to change so that we do not have schema on write, we have schema on read, and we no longer have to build data models, predetermined data models, because we can assemble data through Hadoop and other open source technologies to allow us to build structured and unstructured data to drive cognitive learning. The other thing is, our traditional planning assumed that we were going to put data into fixed hierarchies, and we would know enough when we put in the planning system to be able to determine what those hierarchies are. However, as we move into the autonomous supply chain and autonomous planning, we no longer have to assemble data into fixed hierarchies because we'll use ontologies to do that alignment. In addition, we believed that the enterprise would be the center of value networks and that enterprise connectivity would come through ERP. We now know that my ERP to your ERP to their ERP is not sufficient. And so what we're going to see in the evolution of autonomous supply chains is the evolution and adoption of blockchain with disintermediation around nodes and node definition, which allows us to redefine supply chain finance, supply chain lineage, and hopefully redefine EDI. Now, today's world is all about descriptive analytics, which is a set of analytics which allow us to visualize the current state. And we've got a lot of advancements in the last decade around descriptive analytics. Tools like Click and Spotfire and Tableau are all tools that are descriptive analytics. And our predictive analytics are the traditional advanced planning systems, which assume data in, a data model, data out, and the assumption that we could model in a linear optimization the output. So these 4 paradigms have really got to be questioned as we think about this new frontier of the autonomous supply chain. The other opportunity is the fact that we have put labor to planning, and this group of people that are planners are not very happy. They spend all their time in meetings. They don't really feel like they have time to plan. They don't feel like their organizations understand planning. Folks tend to, ask them to do crazy things like just go back and fix the forecast, which you can't really fix the forecast when you have 60% error, or you've got 80% error with 30% bias on a new product launch. And so as we look at planning productivity, we've put groups of people into jobs that have very low satisfaction rates and feel like they're fighting an uphill battle and that their organizations don't understand what they do. In addition, in the last decade, we've actually gone backwards in the evolution of planning architectures. As we went from the best-of-breed world in the 1990s to what's sometimes referred to as a ERP2, which assumed that ERP was the backbone of supply chain planning, people implemented architectures, but they implemented them badly, and many of the optimization engines were not equal to the tasks of companies. So one of the things I do is I go and I benchmark the maturity of supply chain planning processes, and this is pretty typical where you'll have maybe an advanced network design group or not one at all, but we won't really have the connection of that network design group into sales and operations planning, and we may not have a close handoff between tactical planning to operational planning to executional planning to transactional data. So when companies do planning well today in the current hierarchies, they will have a well-defined hierarchical planning definition with clear handoffs between these planning applications. Now, as we think about the autonomous supply chain, we have the opportunity to redefine planning. Question is, should we combine tactical and operational planning? Should we combine the tactical supply with procurement to be able to look at more concurrent planning? I think all of this is open for discussion, but we've got to walk before we run. And so what I recommend that people do is take the transactional layer, which is typically ERP, and start to play with some of the techniques that I'm going to talk about today and the current architecture to improve pieces, and then over time work on the evolution of autonomous planning and autonomous supply chain. So this whole world of next generation systems, right, is an open area that many people are struggling with. And, you know, when we look at talent, today the top challenges facing companies and facing labor in training is how do we build this next generation of supply chain thinking to be able to think and imagine what the world could look like. So this is a gap, and I'm going to define what the autonomous supply chain is and then come back and we can talk about how we close that gap. So Helen, do we have any questions so far?
Yes, we did have one question so far, and that question was, can you give us an example of how unseen data might drive value in the future?
Yeah, so unstructured data, sentiment data, weather data, GPS data, all of that unstructured data, warranty data, quality data, return data is all data that helps us to understand markets, understand position, and that unstructured data is not used today because the only data that we're really using are transactional data elements around lead times and cycle times and also times around, you know, orders and shipments. So as we get into the world of the autonomous supply chain, we're going to be able to use structured and unstructured data. Does that help?
Yes. So moving into the autonomous supply chain, what do you think some of the most promising technologies will be?
Well, I think it's going to be a combination of cognitive computing, in-memory, and also Internet of Things along with sensor technologies. And let's get into that now, and then let's come back, okay?
Okay.
So as we think about the autonomous supply chain, we've got to think about analytics very differently. You know, today's analytics are really based upon what I call alphabet soup analytics, right? It was, you know, reporting around SRM, CRM, ERP, ATS, PLM. And as we think about the autonomous supply chain, we have to think about analytics that can allow us to sense and respond across the alphabet soup so that we're looking holistically at an analytics layer that stretches between our transactional and our executional systems into workforce productivity. And as we do that, we have certain applications that are going to be in the cloud that will be federated across parties, certain applications that will be streamed, like Internet of Things, which is about streaming data architectures. I'm real excited about some of the work that's happening with Apache Spark, and data that needs to pull to be able to drive new insights. So the combination of clouds, streams, and pools in between our applications and our workforce productivity layer helps us to be able to get the start of the autonomous supply chain. So many times people will come and they'll talk to you about, cognitive computing or artificial intelligence, and, we've kind of got all these words bandied about, and one of the things I want to try to do is give you an understanding of the definitions that I use, and there's no industry standard definition, so I'm just going to help you with what I use so that we can be on the same plane for this conversation. So predictive analytics allow us to have a defined data model and to use algorithms to take data in, optimize within a data model, and drive data out. This is the traditional approach of advanced planning. Across all of our planning hierarchies and across all of our planning horizons, we have predictive analytics where we take data in, we have a predefined data model, and we drive data out. Now, the difference between predictive and prescriptive analytics is predictive analytics tell us exceptions. Prescriptive analytics not only tell us exceptions, but sense on what is happening and tell us what to do about the exception. So one of my favorite examples of prescriptive analytics are Google Maps. So I'm driving down the road, I've got a map, and Google senses that there's a road blockage down the road, and so an exception is sent to my phone, and it says not only is there a barricade down the road 5 miles, but we recommend that you get off here, and if you do, you'll save X amount of time. That is an example of prescriptive analytics. We have very few examples of prescriptive analytics in supply chain today, but they're coming, and I'm working with a number of best-of-breed vendors that are working on prescriptive analytics, particularly in transportation visibility tied to GPS data, and we find that the average company has 5 telematics inputs. So synchronizing the telematics inputs and being able to get prescriptive analytics is an opportunity for us. Now the next layer is text mining and pattern recognition. Text mining is used in many different applications. So it's used in sentiment analysis to look at what do customers think from social. It's used in warranty analysis to say why are we having warranty or quality issues. It's unstructured data. It's data that's not in rows and columns that allows us to mine text and see patterns. We also say the evolution of pattern recognition. An example of pattern recognition is Technology, which evolved for demand sensing, which is recognizing patterns in downstream data. Pattern recognition is a more advanced concept that doesn't require a data model and is really sensing off of patterns. Now, we are moving into machine learning, and machine learning is a wonderful application for master data and the resolution of planning master data or the resolution of differences. Machine learning is pattern recognition that is more advanced, that has intelligence on it that says not only recognize the patterns, but tell me what the patterns mean. Cognitive computing takes it one step further and applies a rules-based ontology, which is analogous to a data model in predictive analytics, but an ontology is the representation of data, structured and unstructured data, to enable relationships for the computers to start to learn. So it can take planning data, it can cross planning horizons, and it can also be redefined for rule sets like allocation or ATP or inventory management, where yesterday's solutions used to take single ifs to single thens for ATP or allocation. The rules-based ontology aligned with cognitive computing can allow multiple ifs to multiple thens. So it allows us to do more intelligent customer policy to inventory, or available to promise within the flush period, or allocation of products based upon what's really happening in the market, or the ability to model attributes and characteristics of planning. So 7% of companies today are experimenting with cognitive computing. It will start to redefine decision support. In fact, I think we're 5 years away from the redefinition of decision support. And it will start in the blocks of planning that I showed you earlier, and then evolve to be able to have a rules-based ontology that will cross over strategic, tactical, operational, and executional planning to be able to stretch across the supply chain. And the dots in this ontology, the orange, the yellow, the green, could represent applications that are connected. So when we think about, planning today versus planning tomorrow, the current state is that people come in the morning and they get their coffee and they wait for the batch jobs to run, and then they get their exceptions. And it takes a while to manage the exceptions, and then they may go to a meeting, and then they'll come back and they'll continue to work on the exceptions. And the days are pretty long, and they're filled with lots of meetings, and it requires a lot of work. What I think the future state of planning looks like is that people will come to the office, and instead of a screen that they punch in data or a long laundry list of exceptions, they'll basically talk to the computer. Good morning, what happened last night? And the computer will say, well, I fixed these exceptions, and these are the ones I want you to go work on first, and here's my recommendation for this. So I think we will have a totally different interface, and we will have the intelligence that will tell us which exceptions were corrected and which exceptions need to be corrected. And then the system will continue to learn, and it will enable the insights that we don't know to ask. Today's data models are based upon our limited view of the world and our paradigm, and they don't adjust. And so this evolution from the current state, which is very manual, very iterative, very batch, to the future state, which is more prescriptive, more automated, and deals across time horizons, will happen in the next 10 years, but I think the evolution of cognitive computing into current planning architectures will happen in the next 5 years. The other thing that's going to happen is the evolution of the Internet of Things, and this is the example that I talk about a lot. This is Lennox International, and Lennox International wanted to redefine service for their heating and air conditioning units, and their prior work was that the United States was in large blocks, and they didn't recognize the seasonality of the system. But what they worked with was the product development teams to say, could we put sensors in our air conditioning units that would allow us to sense real-time the condition of the unit, and instead of people calling in and blocking a time, could we basically call them and tell them that they had a problem? Now, this data also goes into planning systems that looks at how are systems doing and when will we need replenishment. And it goes into a call center that allows people to basically call homeowners and say, we think you may have a problem, we need to schedule maintenance. So this is an autonomous supply chain that enables the ongoing sensing of what's happening in the units. And instead of predicting what's going to happen with spare parts, actually looks at the state of the unit. Now, another part of autonomous supply chains, we had a prior discussion on Internet of Things with Savvy Technologies, and Savvy is working on AIS vessel location, which one of the issues that we have with slow steaming and also larger ships is we have lots of containers that are on ships that are slow to get off, and we don't know where they are, and also the containers that are coming to the ships on the truckloads or in drayage. We don't know where they are either. And so therefore, we're not very good about availability in ETA or estimated time of arrival. And one of the things that Savvy's been working on is if we use sensors and we connect to the Internet of Things, what is the difference of the ETA? And we found about a 45% improvement. So if we can sense and we can tie this unstructured data into cognitive computing and rules-based ontologies, and we can use sensors like AIS, and we can use telematics and GPS, and we can use the Internet of Things, then I think we can start to build what I call outside-in processes. Today's processes work on data that's batch and often latent, and the optimization takes time, and the exceptions take time. And so to me, the autonomous supply chain includes Internet of Things, cognitive computing, rules-based ontologies, and starts to redefine our processes. Now, there's a couple of questions, Helen, I'm just going to go ahead and answer. One is, what's the difference between pattern recognition and unsupervised machine learning? They're very similar. Both are types of machine learning. Most pattern recognition is supervised by the machine, but they're very close, and I think that they're similar enough for interchangeability. Henry says, wouldn't it really be sense, analyze, and respond to make sure that you respond in an optimal way? Yes, but the analyzation is not our traditional way that we analyze, and that's the point that I was trying to make. Octavio said, how will ERP and mainframes be able to implement in the autonomous supply chain? Well, I think ERP remains our system of record. I don't think that ERP will be a mainstay player in the autonomous supply chain. I think the evolution of decision support and Internet of Things is going to happen around ERP, although some ERP vendors beg to differ with me. I think we'll first see the best-of-breed solutions evolve and redefine these processes outside in, and then it will be adopted by ERP. So I say to people, take your ERP system, harden it, try to not have to touch it, use it as your transactional system of record. Even take your APS systems, your advanced planning systems, use those as your planning system of record, and start to use some of these new technologies within the frameworks to be able to write into the systems of record to be able to use this data. Andy says, what areas of the supply chain do you see that's the furthest ahead in using unstructured data? In unstructured data, I see that sentiment analysis or social text mining to be able to look at how the customers feel about our products is one of the furthest areas away. Quality and warranty data and unstructured text mining are also moving quite fast, as well as the evolution of GPS data and telematics. And for cognitive, so the evolution of unstructured text mining is moving in a different area than cognitive. The cognitive computing test cases that I'm following are around the redefinition of decision support, either in supply chain visibility, so be able to look at a rules-based ontology for supply chain visibility, to use sensor data like AIS and telematics, and to be able to redefine visibility, or inventory order matching, or deduction rules matching, or the redefinition of ATP, or the redefinition of forecasting, or the redefinition of price management. Of the 7% of companies that I'm working with that are working on cognitive, almost every company is doing something different. It's not, something that you can copy. It's really people are starting where the business pain is and then growing from there. But the cognitive computing capabilities are so expansive that, it gives us a lot of range of opportunity. So those are some of the evolution of planning. Now, the other thing that I think is important for the evolution of the autonomous supply chain is the redefinition of B2B. And one of the things I write about a lot is, where we are on B2B and the fact that 40% of, our value is really outside of the four walls. Some would argue that it's 85% of cost. And we move documents, EDI, much the same way that we've done for 40 years. And it's analogous to getting mail out of your mailbox, right? Most people don't send mail anymore. They don't pay, by paper check. They pay online. But if you think about going and opening your mailbox, you've got to open the letter. You've got a letter inside, and it's, one directional, and it's typically late. It takes 2 to 5 days to get a letter. And if you want to reply to the person, you've got to either write them a letter or call them. So it's not bidirectional and it's late. EDI documents are very similar. And so as we're working on the network of networks, one of the things we're working on is could we have multi-tier canonicals? And a canonical is a representation of a multi-tier process. So one of the issues that we have is we don't know how to share data very well. How do we share forecast data effectively? We don't have a good answer to that. Or how do we share production schedules? And so one of the things that we're working on is what does a multi-tier process canonical look like? And then how can we have cognitive computing on multi-tier processes and many-to-many architectures? And what does the visualization of that look like? Will there be, some kind of analytics that will help us with benchmarking? And what is the evolution of blockchain, which is an immutable ledger across a disintermediated set of parties? So one of the things that we're working on in the network of networks, which we'll be talking about at our upcoming conference, is the use of blockchain and the definition of blockchain, and perhaps the work that we're doing in our current tests to write once into supplier data across networks like E2Open, Analytica, and SAP Ariba, so we can improve supplier onboarding. But the other use cases that we're starting to look at, like could we have traceability across multiple parties using blockchain and the Internet of Things? Could we redefine supply chain finance? And this is actually something that I was talking to some representatives from the United Nations the other day about around supply chain finance, particularly in Latin American countries and Africa, where we don't have traditional supply chains, and could we disintermediate banking? And so when we get an ASN and a proof of delivery, could we automatically pay and disintermediate the traditional bank? And the other thing is, could we start to work on the alternatives to EDI? So, a combination of lineage and supply chain finance with blockchain is very exciting. One of the issues is that most of the blockchain work today is in one-to-many, not in many-to-many architectures. And so one of the things that we're starting to work on with IBM and other blockchain providers is what does security need to look like for many-to-many architectures. And then interoperability, could we also have a rules-based ontology that's combining with the blockchain capabilities to allow us to write in between companies for cognitive computing interoperability to be able to look at the translation of data? A lot to think about and all very exciting. So, Ellen, let's look at some other questions we might have. Any thoughts?
Okay, yeah. We have one more question from an audience member, from Shelley.
Uh-huh.
She asked, who are the key cognitive technology vendors for the supply chain?
Yeah, so the key cognitive computing elements are really around decision support and automation of rules and automation of master data. And so as we think about those in the autonomous supply chain, we're kind of clunky today. We don't do any of those three things very well. Any other questions?
Could you explain what you mean by eliminates the need for master data management?
Yeah, so master data is a tough area. In fact, we've got lots of people that, are in master data management roles. But the issue is that the context of master data needs to be different by the need state. And so we need adaptive master data, and it needs to be more than transactional master data. There needs to be planning master data, things like lead times and plant open dates and cycle times are not fixed definitions, they're variables. And so as we look at the evolution of planning master data, it is the ability to take data to be able to build planning master data repositories and to be able to read off those repositories in terms of lead times and cycle times and, rules associated with the supply chain. So Helen, if it's okay with you, let's move forward. People have to really, people have to absorb the technologies based upon their own DNA. So, we find about 14% of companies are early adopters and 35% of companies are late adopters. And 7% of companies are experimenting with cognitive computing today. People need to be able to adopt technologies based upon their own DNA. So certain companies will be early adopters. If you're not an early adopter, don't try to push, a technology project down the throat of a company that's not an early adopter. But follow the work that's happening with this whole space and recognize that we're really at a very exciting time. I've never seen such advancements in both analytics, memory, and also sensors that are happening at the same time. And, as you look at the promise of this, reach out to your finance team and think about process innovation, because you need a way within your company that you can evolve. Today, most companies cannot invest in technology unless there's a definitive ROI. So you have a project and the finance team says, okay, well, what's the ROI of that project? And if it stacks up to be a great ROI, then you get the ability to invest. But in these new technologies, we don't know what the ROI is. And so we need small, scrappy groups to be able to test and learn and evolve and to work with process innovators. Then these process innovators are best-of-breed technologies that really need places to evolve and co-development partners to evolve with. So we've got to remove the handcuffs. We've got to have the discussion with finance that says that these processes are so promising. We need some money, and maybe it's the money that you generate through continuous improvement that you keep a percentage of, to test and learn and to be able to have a process innovation group to do that. And build a stage gate process for process innovation, just like you have for product innovation, where you've got projects and you give go, no-go based upon the ability to solve business goals. But always be sure these teams are very, very vested in driving a business goal. You don't want them just to wander through the wilderness. And, this is not something where you're going to hire a big busload of consultants. This is where you need a small, scrappy team. And a scrappy team are kind of the mavericks in your organization, the people that, question the status quo, like working with technology, like working in areas that are uncertain, and work with process innovators on the technology side and partner with them. Don't strap them with, RFPs and RFQs, but, bring them in and talk to them about ideas that you have and business problems that need to be solved, and roll up your sleeves together. And manage the hype cycle. So when you implement these projects, don't, give, the sky and the moon promises about expectations. Just say we're testing, we're not sure what's going to happen, and manage the hype cycle so that, you can come out, as a winner. Some things aren't going to work. And, as we test and learn and manage the process innovation cycles, we've got to work on having the right DNA to allow process innovation with new technologies. Today, we don't have that kind of environment. We have a project-based environment that has to have a required ROI, and we believe that we paint the current state and the future state, and then we put in a project to do the bridge between the two states. This is very different. We don't know what the future state is. We just know it's very promising. We don't know what the ROI is, but we know it's really promising. And so the ability to test and learn with new technologies, if you're an early adopter, is where you need to currently focus. So, as we think about the autonomous supply chain, I want to encourage people to adopt new technologies and challenge current thinking. 90% of supply chains today are stuck. The evolution of complexity challenges the current state of predictive analytics. Supply chains today don't sense, they just respond. And we can't manage the supply chain as a complex system. So as you look at new technologies, really adopt them with a goal in mind and encourage your organization to take a different path and to challenge the status quo. Other questions, Helen?
Yes, you just got what I think is a really good question. How do I proceed to try to get a project approved without a defined ROI?
Well, I think you've got to self-fund it. As we look at the ability, most supply chain leaders are driving continuous improvement processes and contributing millions back to the corporation. I think you have a conversation on digital transformation with the leadership team and say, could I keep 25% of this and test and learn on new technologies and, start this process innovation roadmap and, self-fund it.
Thanks. Have you seen any early adopters? Do you have any examples of any of those?
Yeah, so, the early adopters that I think are exciting, Lennox Industries is one that I talked about on Internet of Things. There's also a very large household products company that I can't say the name of that is doing a lot of great work on test and learn and ETA. At the upcoming Supply Chain Insights Global Summit, we'll have a presentation from Unilever on trade promotion and cognitive computing. And we'll also have a presentation on pattern recognition and text mining. And we'll also have a presentation by AGCO on Internet of Things and the redefinition of digital manufacturing into production planning, and by Jabil, who's doing a lot of work around 3D printing and digital manufacturing. So, as I think about, who's doing the most work, it's supply chain leaders like Cisco, Intel, P&G, Unilever, Lennox International, Costa Coffee. On the screen right now is a presentation that we had last year from Costa Coffee, who was doing some work on the Internet of Things. And so as we think about this whole evolution, I would encourage people to understand what best-of-breed providers are doing today. Most of the innovation is happening from the best-of-breed providers. Push back on the status quo and start to innovate. Other questions, Helen?
Oh, yes. Sorry, I was muted there. Do you feel that cloud-based transportation management systems provide enough end-to-end visibility and automation to provide long-term value for supply chains?
Yeah, I think transportation is a great place that we'll start to see innovation with the autonomous vehicles. We actually have a presentation on that also at the Global Summit. And, we have a tremendous issue with drivers and GPS and telematics data and the redefinition of transportation optimization. I think that whole space is going to be quite an exciting space in the future. Shelley's asking the question, where's the low-hanging fruit? It really depends upon the industry. I think you've got to start with, is it digital manufacturing for you to redefine maintenance? Is it redefinition of planning for forecasting and tactical supply? Is it the redefinition of rule sets, perhaps allocation or ATP or inventory management's not working very well? I think you've got to really ask yourself the question of where should you get started based upon the goals, and make sure that you always keep those feet very rooted in goals. Helen, other questions?
Henry asks, are there any examples where blockchain is being used to improve supply chain planning capabilities?
Not planning capabilities, but executional capabilities, visibility, supply chain finance. We have some work going on with a very large retailer in China around food safety and gray goods. And we also have some work going on supply chain visibility of containers. So I think blockchain is a very promising technology. And we look like we have a question, has technology improved inventory management? This company is still pretty much fiscally counting all of its hard assets. Actually, I think technology has greatly improved inventory management when people really are serious about it. Unfortunately, most people, when they say inventory management, are packing safety stock, which, safety stock I think is not the opportunity. I think it's cycle stock, and I think it's real-time inventory management. The automation of sensors to allow us to have real-time inventory management along with form and function of inventory is transformative, I think, on inventory. I think Glenn's got a question on robotic processes, and we're actually going to have a number of discussions on robotics at our upcoming conference. We invite Sawyer every year to come, and Sawyer is a collaborative robot which allows you to train a Sawyer. And I'm amazed in the last 5 years how much more capable Sawyer has become. In the first year, he could do very limited tasks, but this year, I don't know if he's going to serve appetizers or drinks, but he's definitely come an awful long way, and his price point has actually gone down too. So robotics, I think, has a great role to play in warehouse management, kitting, late-stage packaging, and the cost point and the value proposition for robotics has greatly changed. One of the things that's asked is in-memory database in structured and unstructured data, and how is this feasible? And our open source technologies, Hadoop and Kafka and Apache Spark, give us a whole new world of capabilities, and I would encourage people to look at what can be done with those technologies. I think that most of our current thinking is very set upon relational databases and data models that are, defined. And so as we get into this new world and we look at open source and parallel processing and, some of the things that can happen there, it gives us a whole new world. All right. Any other questions, Helen, before we close?
No, Laura, I think that's it.
Well, we appreciate having people join us today. I encourage people to join us at the Global Summit. This last week to sign up. We'll have 110 supply chain leaders at the Global Summit. We'll be talking about the combination of autonomous vehicles, robotics, cognitive computing, and Internet of Things. I think it's not one technology. I think it's a group of technologies that can be transformative and really drive processes outside in. We'll also be playing our new game at the summit, which is called Supply Chain Impact, which allows us to look at inside out and outside in processes and the value proposition of using outside in data, channel data versus order data. The teams will play against each other in a modified sales and operations planning environment. And each round of the game will write to the balance sheet, give a theoretical market cap, inventory turns, and operating margin. The reason why we're doing this is to help people to understand the supply chain as a complex nonlinear system and the impact people can have on the balance sheet through supply chain strategies and really driving autonomous processes. So encourage people to come, play the game, consider bringing the game inside their organization to really drive and think differently and drive new outcomes. And I just encourage people to imagine the future. Thanks for joining our webinar today, and we appreciate your insights. Thank you.
Thanks, Laura, and thank you to everyone who joined today. A few things to share before we end. As I mentioned, we will send out the slides and the recording link to everyone on the webinar, so keep an eye out for a follow-up email from us. We also encourage you to engage with us on social media by following us on Twitter, Facebook, and joining our LinkedIn company page and following us on SlideShare. You can find this information in the slide deck. Thank you.